Hey folks, 2017 short questions here. So we kick off. So the first thing we've been asked is this cube here to complete the axisymmetric projection of the cube and the given lines. Okay, so the first thing I would do is I try to finish out the main structure there. That's that face there. That's part A there. Next thing we've been asked there is to determine the true angle between the lines AB and CD. So the only way we'll be able to do that is by looking in here at 90 degrees, okay? So put on our set squares there. And we have it's a perfect cube anyway, so you can take this height here, 36. Now yours might be slightly different because I printed this out on A4 paper, so don't go by that measurement. With A, I just need to transfer down my other points. That is AB there. And now I need to take up points D and C, okay? So just get the heights over here in the elevation. And so that is the true angle there between C and D. We've been told the graphic below shows the logo for the Ladies Professional Golf Association. It contains a combination of geometric curves and depicting a female golfer. The main curve is the parabola and the club shaft is a normal to the parabola. Okay, so the drawing on the right shows AA, the directress DD, and the focus F of a similar parabola. Locate the vertex and draw a portion of the parabola. Well, a parabola we know has a ratio of 1:1, which is 45 degrees. And if we want, I'll just let that line go on up, we'll need it in a minute. If you want to find the vertex, we'll come up with 45 degrees. and drop down there, and that'll get us our vertex. Now we're just putting a couple of ordinates in either side, so anywhere at all. I'm just going to pick one in the middle there, one, maybe one more. And bring them out there to the latus rectum, and we'll do the same here with this guy. Do the opposite there, bring them out there. Get your compass, folks. Set it there, drop out that arc there. Set your compass at that distance there. Sorry, this distance now, and I should swing it the other way. That is my point there. All your swinging is done from F. Drop it out. Drop it out. And that gives 1, 2. Of course, this is the point here. 3, 4. Okay. And 5 down here. Now, what you can do there is we'll just drop down these points and we'll mirror them down. And we can do on our curve then as well here. So all you're swinging from F, bring your bring up any ordinates, bring them out where it hits the latus rectum, put your compass on F, swing it down, and same the other way. So this one was different within the middle, it was swinging to the right. These guys swinging out there to the left, okay. That's the part of the first part A done. Part B, locate a point on the curve which is 30 mil from the directrix, okay. So if we throw down there, and mark out 30 mil. Now this could be applied to the top or the bottom. We'll put it up on the top here. That's 30 mil out from the directrix. That gets me a point P there, okay. Now, it says point P is 30 mil out from the directrix and construct a normal to the curve at point P. So the first thing we're going to have to go ahead and do actually is we're going to have to draw it. I'll get a tangent, so I'll just do this lightly. The handiest way to get a tangent, any point on the curve, join it to F, where it hits the fork F, come off at 90 degrees. And this point down here on the directrix now, we could draw a tangent to. And similar to different kinds of conics, the normal is always at 90 degrees to a tangent, okay? So that's our normal coming in there. And that's question 2. We're asked here, design for a patio fireplace based on a regular solid is shown. The drawing shows the elevation and plan of a similar solid. All faces are regular pentagons. Using the given x1, y1, draw the true length of the line of intersection between the face AB and hence determine the dihedral angle, okay? So down there in plan view, we can see that this is A and that's B there. So we need the true length of that line of intersection. So run them out there. We'll get our height from elevation. So take that measurement there. mark it off. That's the true length. Now we need to bring 1 point from each plane. So we'll bring these 2 points here, we'll call it S and T, and them out. And now we're going to look down along that true length line and bring the point from each plane. X2, Y2. Now you always know you're measuring off the right XY line because it's parallel, that line of intersection there, okay? And both of those will be the same distance away, both those points. And only this way, when they're the same distance, will you end up with a point view. Okay, so that line of intersection is a point view. And we just get the distance back then to S and T. There's S. That gives our dihedral angle. Hi, so part B here, determine the center point of face B in plane and draw the projections of a sphere which rests on the horizontal plane and is also in tangential contact with the center of face B. Okay, so I need to find the center of face B, so I'm not looking at the face straight on there in any view. So what I'm going to do is I'm just going to knock this down onto the ground. And the width won't change if we do this. That point will run out there. Now we know the length of the base, so we can just catch that quickly there. Set our compass there. He's going to hit that line there, and he's going to hit this line over here, and then that'll get us the top there. So that's a quick way of drawing our pentagon. Now we need the center. The center is going to be somewhere along there, so I'm just going to bisect any one of the angles there, and that'll find me the dead center. And now I have the dead center. Another thing I'm going to need is I'm going to need an edge view, because from doing solids in contact, the vast majority of the time, if we have a sphere and it's going to be touching a flat surface, okay, we're going to need to set up an auxiliary and to see this plane B as an edge view, okay. So I've kind of already set that up there. So we're going to be looking along, this is a true length line on the ground here. So we're going to be looking along this. Looking up along there. That'll be the base there. Now, I know from flattening out that pentagon as well there, I know the height from the top to the true length from the top to the bottom. Okay, so if I'm looking at an edge view of that there, that would also help me figure out this. But the handy thing about having the center point now, the dead center of the pentagon that we knocked down, is if I bring up that now, and we get up as far as there, and put down my compass, and I know that's going to be the center of the point there in the edge view. So that's an edge view of B. Okay, and just by bringing up that finds me the point where the sphere is going to be in contact. Okay, now I'm just going to lightly shade in this so it's easier to see. So that is the pentagon I knocked down there. That is the outlines of it there. And now we have the edge view. Now, if we have a sphere that must be in contact, that means here, that means somewhere along this line here that I'm bringing out, get a different color there, somewhere along this line now must be the center of the sphere. Now, from doing solids in contact before, we know if we bisect an angle, the ground and the edge view of the plane it's touching, this is a possible path that a sphere could be on, was touching those two. But to get the one of the specific size we want, it will cut that red line coming out there. So that's the place to put my compass now. It should hit the ground and hit the edge here. Sorry, no, it's very small. It slipped. So all I'll do now is I'll bring that sphere back down. Back down there. That's where it's going to be in my plan view. And just check the radius again. And we draw it in there. And then we'll just run this point up here. Just be careful with these kind of questions. A lot of the times people will draw it in plan, and then sometimes I see they forget then to go and draw the elevation as well. Okay, so that's A3 done there. Hi, so this is A4 and the last question in 2017. So we're told here the plan, elevation and in view of the archery target are shown. The line PA represents the plane of an arrow just before it hits the target. The arrow travels horizontally in a straight flight path. Part A, draw the arrow PA in the in view and elevation. So they're telling us there that it's going straight in horizontally. So I'm going to bring up. We're going to need to see this line there and there, and over here it's coming straight across there. I'm going to need that in a moment. Now, to get rid of all this messing, swinging a compass, I'm putting in this, okay, just to speed things up. So getting point A, bring it across there and bring it up. Okay. That's the arrow now in the in view. And we have it over here. P and A are coming up here. So we have the arrow there in elevation. Part B, determine the projections of the arrow when it hits the target. So we're told there it's going in a straight flight path. We can see that in our in view. So we can set our compass to this here. Just step out that distance there. That is the arrow when it hit the target. We're going to drop it down. We're going to need this in a moment. And we're going to bring it across. I'm going to drop down this as well. Bring it across. And we have the flight path as well here in plan. So it's going across there. So that's going to be our arrow there in plan view. Just to get an elevation then. Bring up these two end points. And that is the arrow when it strikes the board. The last part now, part C, is a second arrow traveling in a straight line. Also passes through point P and hits the target at the bullseye. Okay, so we can see the bullseye on the board is here. Okay, BE, bullseye. So it's hitting that. That's the flight path of it there. And we've been asked there to determine the true angle between the two flight paths. So down here, it would be going from P straight to the center. Okay. And we need to know the true angle between these two arrows. Now that is an apparent angle there because this is a true length, this line, because he was parallel up here. Okay, so that's a true length line. This guy is not. So this is almost kind of similar to having, if I can just do a quick sketch there, if you do a cone, and that's the center, the axis of the cone there, and we have a generator there, but it's not the true one. What we need to do is to revolve that out, okay, so that we're looking at bring it out around to the extreme generator, okay, and by that way we would see the true angle. Now it's quite similar to this. Let this be like almost like the axis of a cone. I know the arrow goes in there and it hits here. Now if that was to come out, if we were treating that like a cone and a generator, we wanted to bring that around, and I do out a line there perpendicular, okay. Now this is a true length line here. If I'm not able to simply revolve around it as in a cone as I usually would, but if I knew the true length from here to here, I could figure that out, and I've got the true length up there because we're looking in at it at an edge view. So I can put down my compass here, set it on P, set it on P down here, and where it crosses that coming in there, I'll be able to draw in that. So this guy, it's the same as that guy there, okay? And when that is set up, now I can see, in this case, I can see the angle between the two flight paths, which would be the same almost like the angle between the axis and the extreme generator, okay? So I'm seeing that angle there that we're looking for, and that is part C. So I hope you found that useful, folks. More videos to come. Take care, stay safe.